now that we've talked about coterminal angles and we were just working in degrees, now we're going to shift gears, and for the first time I'm going to teach you a little bit about drawing angles in radians. So if you open up this tab, all you have is a blank coordinate grid, and really small, we're going to go ahead and, just for the sake of bridging the gap from one math language to another, we're going to put 0 degrees, 90 degrees, 180 degrees, 270 degrees. And hopefully you filled out one of these bad boys yesterday, and we can look at that to help us know what each of those quadrantal angles are going to be in radians, so that we don't have to do the grunt work of converting. So you can see 90 degrees is pi over 2, 180 degrees is pi, and 270 degrees is 3 pi over 2. An easy way to remember it is, you know that 360 degrees is equivalent to 2 pi, and you know that 180 degrees is equivalent to pi radians. So to get the other two, you would just go halfway between 0 and pi is pi over 2, and halfway between pi and 2 pi is 3 pi over 2. So those are our quadrantal angles in radians. Those are like your postmarks, okay? That's what's going to help you know where your angle that you're given is going to fall. So, for example, let's start with pi over 4. In order to graph pi over 4, we're going to have to compare pi over 4 to all of these angles in radians. It's really difficult because they have different denominators. These guys have a denominator of 1, these have denominators of 2, and the one we want to place has a denominator of 4. So a lot of times what I tell students when they're first starting is that they need to convert all of the other angles to pi over 4, or to a denominator of 4. So for example, pi over 2 becomes 2 pi over 4. Because to get a denominator of 4, we double 2, and what you do to the bottom, you do to the top. And then we're going to go over here. Pi is going to become 4 pi over 4, so that we can compare where pi over 4 should fall. Now we actually don't have to go any further right now, because 1 pi over 4 is surely less than 2 pi over 4. So it's going to go somewhere in here. It's actually going to go halfway. And then sometimes whenever I draw an angle, I put how big the angle is at the end of the arrow, so that you know how big it was. Now let's go ahead and try another one that doesn't fall in the first quadrant. Now I'm going to do it in a different color. This one I'm going to do 5 pi over 6. So this time we have to get equivalent denominators of 6 in order to properly tell where it's going to fall. So this first one, to get a denominator of 6, we have to multiply 2 by 3. What you do to the bottom, you do to the top. So we'll have 3 pi over 6. So we know it's past that. And over here, pi is going to become 6 pi over 6. And it's less than that. So we know it's going to fall somewhere between 3 pi over 6 and 6 pi over 6. And actually, it should be closer to this axis than this one. So I'll go ahead and draw that in. Terminal side, initial side, draw my angle theta, and it's 5 pi over 6. Okay, so let's go ahead and do one more. Let me see if I can find another color pen. Let's just do plain old black. And I'll try to do one that's in either the third or the fourth quadrant. Let's do Oh, I've got one. 5 pi over 3. So now we have to go back and we have to try to get all of these denominators to be a denominator of 3. We have to compare 5 pi over 3 and pi over 2. But actually there's no way for 2 to become a 3. There's just no way to multiply that. So what we have to do instead is actually make this fraction have an equivalent denominator of one we've already created. So we can get this angle to have a denominator of 6, and we can compare it to 3 pi over 6. So 3 to 6, you have to multiply by 2, so this is going to become 10 pi over 6. So we know it's definitely past that. Now let's go down to pi. Pi would be equivalent to 3 pi over 3. So our angle is 5 pi over 3, so we know we're going to pass that. So we keep going. Now we're down to 3 pi over 2. Well, 3 can't become a denominator of 2, but we do have its equivalent with a denominator of 6. And this 3 pi over 2 can be multiplied to get a denominator of 6. So that's what we're going to do. Now to get this denominator, we say 2 times 3 gives you 6. So 3 times 3 gives you 9 pi. So we know that our angle, 10 pi over 6, is past 9 pi over 6. But is it less than 2 pi? Well, if we make this have a denominator of 3, we have to multiply by 3, and we get 6 pi over 3. So yes, our angle is going to fall somewhere between 9 pi over 6 and 6 pi over 3. And it's actually going to be closer to the 6 pi over 3. So we'll go ahead and draw that in here. And that's my terminal side. Here's my initial side. And I'm going to draw my angle. And ta-da! So that's really confusing because we have a lot of different ones on the same graph. Normally you won't do that. But hopefully that gives you an idea of the work that you have to go through to graph angles when they're in radian form. And no, I don't want you to just convert them to degrees and work with them, because after you get used to this process, you will start to know where these angles fall in radians. And the sooner you get used to it, then the easier later problems are going to be, because you won't get tripped up on this littler stuff when you have bigger things to think about. So that's all for today. Go ahead and glue that in on page 5, and we will cover some more practice in class.